Aldehydes and Ketones. Introduction. Aldehydes and ketones contain a carbonyl group. An aldehyde contains at least one hydrogen atom bonded to the carbonyl carbon, whereas the ketone has two alkyl or aryl groups bonded to it. The carbonyl group consists of carbon with doubly bonded oxygen, and if it is an aldehyde, it contains R group along with H bonded to carbon and doubly bonded oxygen. If it is a ketone, the carbonyl carbon has two R groups and doubly bonded oxygen. Two structural features determine the chemistry and properties of aldehydes and ketones. The carbonyl group is sp2 hybridized and trigonal planar in shape, making it relatively uncrowded. The electronegative oxygen atom polarizes the carbonyl group, making the carbonyl carbon electrophilic in nature. Aldehydes and ketones react with nucleophiles. As the number of R groups around the carbonyl carbon increases, the reactivity of the carbonyl group decreases, resulting in the following order of reactivity. Nomenclature of aldehydes. If the CHO is bonded to a chain of carbons, find the longest chain containing the CHO group and change the E ending of the parent alkane to the suffix Al. If the CHO group is bonded to a ring, name the ring and add the suffix carbaldehyde. Number the chain or ring to put the CHO group at C1 position, but omit this number from the name. Apply all the other usual rules of nomenclature. Three examples of aldehyde nomenclature are 2-chloropropanol is the IUPAC name of the first compound. The common name is alpha-chloropropanaldehyde. The second compound has the IUPAC name 3-methyl-pentanal, whereas the common name is beta-methylaldehyde. The third compound is phenylethanal, which is its IUPAC name, and its common name is phenylacetaldehyde. Like carboxylic acids, many simple aldehydes have common names that are widely used. A common name for an aldehyde is formed by taking the common parent name and adding the suffix aldehyde to it. For example, formaldehyde, which is the common name for methanol, is obtained from formic acid. Similarly, acetaldehyde, which is the common name, is obtained from acetic acid, and benzaldehyde is the common name for the third compound, and its IUPAC naming is benzene carbaldehyde. Greek letters are used to designate the location of substituents in common names. The carbonyl compound having C double bond O with immediate carbon atom is given the letter alpha in the common naming, and the substituent carbons are given beta, gamma, and delta positions. Now we'll see the nomenclature of ketones. In the IUPAC system, all ketones are identified by the suffix ONE. Find the longest continuous chain containing the carbonyl group and change the E ending of the parent alkane to the suffix ONE. Number the carbon chain to give the carbonyl carbon the lowest number. Apply all of the usual rules of nomenclature. With cyclic ketones, numbering always begins at the carbonyl carbon, but the 1 is usually omitted from the name. The ring is then numbered clockwise or counterclockwise to give the first substituent the lower number. Most common names for ketones are formed by naming both alkyl groups on the carbonyl carbon, arranging them alphabetically, and adding the word ketone to it. For example, the IUPAC name of the following compound is 2-butanone, whereas in the common name around the carbonyl carbon you have a CH3 group called as the methyl group and a C2H5 group or CH2CH3 group, which is called as the ethyl group. Alphabetically, ethyl comes first. Therefore, the common name for the compound is ethyl methyl ketone. 3 widely used common names for simple ketones do not follow this convention. They are acetone, acetophenone, and benzophenone. 2 examples of ketone nomenclature are IUPAC name for the first compound is 2-methyl-3-pentanone, whereas its common name is ethyl isopropyl ketone. The second compound has the common name meta-bromoacetophenone, or the IUPAC naming is 3-bromoacetophenone. Sometimes acyl groups must be named as substituents. The 3 most common acyl groups are shown below: formyl group, acetyl group, and benzoyl group. But Do not confuse a benzyl group with a benzoyl group. Benzyl group is a benzene ring with a CH2 substituent, whereas a benzoyl group is a benzene ring with C double bond O present on it. So when a C double bond O is present on a benzene ring, it is called as a benzoyl group.